Welcome to our introduction to XField. There's some uncertainty in the interpretation of any type of geophysical data, no matter how high quality. Using several different types of data can massively decrease the size of these uncertainties.
By integrating seismic and well log data with real-time modelling of gravitational and magnetic responses, XField provides a simple and low-cost way of reducing exploration risk. The graphs above the model show the measured response in blue and model response in red. The blue wiggly line at the top is from FTG data. So what the software is doing is forward calculating the response of this model, which is the red line you can see. The model interpretation as it stands doesn't satisfy all the data. It looks okay on the seismic, but the gravity data is telling us that it doesn't quite work. The idea is you then make small changes to the model, which improves the fit to the gravity data. In this way, we produce something that satisfies the seismic data, but is also giving us an excellent fit on the gravity, and also on the GZZ, the vertical gravity gradient. So this is the principle of how we can use XField to produce this integrated and robust interpretation. XField models can be built on 3D seismic inlines and crosslines, 2D seismic, a scanned image, or a blank background. Seismic data can be loaded quickly from an existing project. Model parameters, while not required, can be entered to improve the accuracy of the potential field modelling. Building a model in XField is as easy as splitting the model up along horizons in your data, dragging horizon nodes, splitting further bodies, or joining bodies together allows easy manipulation of the model. Each body can be given density, velocity, and magnetic properties, from which the potential field model is generated. There's even a function to give a body an elastic half-width to account for the large density variations of bodies not in the plane of section, such as salt diapirs or plutons. Additionally, color, stratigraphic age, and automatic annotation of properties are all easily customized. A body title can be entered, and annotations of body properties can be selected from a checklist. The body title and selected annotations will appear on the model and will update automatically. An interactive map function also allows easy switching between different models in the same survey, extremely useful for matching up different models at their intersections. When working with several intersecting lines, body boundaries on other lines will be displayed in both time and depth, and it's possible to drag and drop body properties to easily populate new models without discrepancies in body properties. The model can be viewed simultaneously in time and depth, allowing the user to compare their model with both seismic and well data. Well data is automatically imported from an existing Petrel or OpenDetect project and can be viewed in depth by checking the various display well options. Wells lying just out of the section of the seismic can be viewed by changing the intersection tolerance. A quality control horizon can be imported, such as the depth to the MOHO, from an existing horizon in OpenDetect or Petrel, to provide extra constraint to the model. These horizons will appear as a red line on the depth model, which a model boundary can then be fitted to. Gravitational and magnetic data from the area can be imported very easily from an existing project. The predicted magnetic and gravitational response from the model, in red, and the observed gravitational and magnetic response, in blue, is recalculated in real time and is displayed at the top of the model. Misfit can also be displayed to help to identify any poorly fitting regions. Several tools make it easy to spot the cause of deviations from the observed gravity and magnetic responses. For example, the response of individual bodies can be plotted to see how they affect the overall model. Note how the brown line changes when different bodies are selected. High and low pass filters can also be applied to both the observed and calculated responses. The frequency of a potential field response depends on the depth of the density or susceptibility change which causes it. Therefore, a low-pass filter isolates gravity-magnetic effects from depth, removing short-wave fluctuations, while a high-pass filter removes long-wavelength trends, showing only the short wavelength fluctuations from shallow layers.
The Northeast Rockall Basin provides a good case study to highlight the benefits of XField.
In this area, Paleogene extrusive basalt flows make very high impedance reflectors, preventing seismic energy penetration to depth and thus preventing confident interpretation of the Mesozoic structure below, even on good seismic. A previous BGS model, built only on seismic and well data, shows considerable uncertainty, where interpreted at all, about the structure below these basalt horizons. An XField model can be built over this old interpreted section and then is easily superimposed on top of a more modern vintage of seismic data, which has potential field observations associated with it. The old model, populated with body properties from a well log in the area, shows a complete misfit with potential field data, demonstrating just how wrong models built on seismic alone can be. Adjusting the boundaries in this model to reduce misfit with the potential field data, while not ignoring the seismic or well constraints in the area, paints a completely different picture of the Mesozoic basin structure in the region. This process can take several hours or days, so is not shown here, but the final result of this process is shown. Instead of a system with only one normal fault set, the new interpretation suggests that there are two, and the gravity data also requires much greater sediment thickness in the grabens. Improving the Mesozoic rifting history is vital for the exploration in the area, as the timing and extent of rifting is the major control on the deposition of the Jurassic source rock.
Thank you for watching. If you'd like more information on XField or any of our software or services, please email us or check out our website.